The chain rule. So the chain rule helps us find derivatives of composition functions, right? So we have to account for that inside function. So we can take the derivative of the outside function and then multiply it by the derivative of the inside function. So sometimes the chain rule, we might be able to avoid it, right? I could look at this function here, 5x plus 3 quantity squared, and I could just square that out, right? 5x plus 3 times 5x plus 3 will give us 25x squared plus 30x plus 9. And then I can do a derivative and say that's 50x plus 30. And I can avoid the chain rule. But there's sometimes we're going to have functions where we can't expand it out, or maybe it just wouldn't make sense to take the time to expand it out. So with the chain rule, so I see this, that f of x is really a composition. So let's do h of g of x. So just formula-wise, if I'm going to apply the chain rule, it's the derivative of the outside times the derivative of the inside. I just have to figure out what the outside function and the inside function is. So in this case, the outside function is some quantity squared, and then the inside function is that 5x plus 3. So if I do the derivative of the outside, right, that x squared, that gives me 2x. Well, x is really this inside function. So I need to have 2 times that 5x plus 3. Then I can multiply the derivative of that inside, which is just 5. So in the end, if I multiply all of this out, that'll give me 10 times 5x plus 3. And I can multiply that if I wanted to. And the only reason I'm going to do that is to show you that it's the same. Okay. So let's do it for this function here. So the outside function is some quantity cubed. So the derivative of that outside would be 3, and that quantity squared. And I'm going to leave it as the 4 minus x squared. But to account for it, I'm going to take the derivative of just that inside piece. So negative 2x. So altogether, I would have negative 6x times 4 minus x squared squared. And I think that as a lot easier than if I were to cube that out to use the power rule. So let's look at some other scenarios as well. All right, so I have a radical here. Let's turn this into a rational exponent. So how about x squared minus 1? That's always power over root, so 3 halves. Then I can do a derivative. So I've got 3 halves, and then x squared minus 1, and I subtract 1 from the power. But then I have to do the derivative of the inside, which is going to be 2x. And then I can clean it up a little bit, because 2 divided by 2 will cancel out, and I'm left with 3x times x squared minus 1 to the 1/2. And you can put it back in its radical form if you want. I leave it because that's just an extra step to do. All right, I could rewrite this one so I don't have to use quotient rule and say negative 7 times 2x minus 3 to the negative 2. So then I can do the derivative of the outside, so that 2 times 7, and then I'll leave the quantity, so 2x minus 3, subtract 1 from the power, and then derivative of that inside, which is just 2. So I'm left with 28 times 2x minus 3 to the negative 3. And we can drop that back down to the denominator if we so choose. All right, so pause the video and see if you can do these two. I'm gonna go ahead and do them, but pause the video and try and see if you get the same thing. So we got derivative of the outside, 2/3. Then we'll subtract 1 from the power. And then multiply by the derivative of the inside. And then I'll just clean it up here. So -16/3 x times 5 minus 4x squared to the -1/3. All right, I'll rewrite this one as well. So -2 times 6x plus 3 to the -1/3. And then derivative of the outside is going to be 2/3 to the negative, let's see if I minus 3, it'll be -4/3 times the derivative of the inside, which is just 6. And I can clean that up because 6 divided by 3 is just 2. 2 times 2 is 4. All right. Let's do some trig functions. And maybe we'll have to combine some other rules here. Okay. All right, so I have cosine squared of 4x, so the outside function is that cosine squared. So that's going to give me 2 cosine of 4x. Then I have to do the derivative of the inside, which is cosine 4x, which has a chain rule within that, right? So this will be negative sine of 4x, and then times 4. Then I have to do the same thing for the sine squared, so that's going to give me, I'll do it in a new line here, 2 sine of 4x, and times the derivative of the inside, which is sine 4x. It's going to give me cosine of 4x times 4, double chain rule stuff going on there. And then let's clean it up. So 2 times 4 times -1 is -8. And then I have cosine of 4x, sine of 4x. And then I'm subtracting off 8. Cosine, sorry. I'm going to rewrite it as cosine of 4x, sine of 4x. So we can see that these are like terms, right? So -8 minus 8 is a -16. So -16 cosine of 4x, sine of 4x. All right, we actually have a product rule to do here. So left times the derivative of the right, which is going to be 2 sine of x cosine of x, because the derivative of the outside is the 2 sine of x, and the derivative of the inside is going to be cosine of x. So left d right plus right, and then d left. So I'd probably write that as 2 x to the 4th sine of x cosine of x plus 4x cubed sine of x squared. And if we want to factor out some things, we can. Otherwise, I would just leave it. Right, sine of pi x squared. So derivative of the outside is cosine. So cosine of pi x squared. And then times the derivative of the inside, which is 2 pi x. And we could rewrite that as 2 pi x times cosine of pi x squared, just because I like constants, or the smaller terms out in front. Let's look at this next one. So derivative of the outside is going to give me 8 cosine of pi theta times the derivative of the inside, so negative sine of pi theta times pi. So if I combine it, we'll get a negative 8 pi cosine of pi theta times sine of pi theta. We got a tangent one here. I'm going to rewrite that as tangent of 2x minus 3 to the 1/2. So derivative of the outside is that tangent of that quantity to the 1/2. So that's going to be secant squared of that quantity to the 1/2 times the derivative of that quantity to the 1/2, which is a chain rule in itself. So 1/2 times 2x minus 3 to the negative 1/2 times 2. So we got secant squared of 2x minus 3 to the 1/2. The 1/2 times 2 will cancel out, so I'm left with 2x minus 3 to the negative 1/2. And maybe it'll look prettier like this. So secant squared of the square root of 2x minus 3 all over the square root of 2x minus 3. Either way is fine. This is fine. This is fine. All right, let's look at this one. So we're going to do derivative of the outside, which is this cosine cubed. So 3 cosine of sine of 2x squared times the derivative of the inside. It's going to be negative sine of 2x, and then derivative of the inside of that. So cosine of 2x times 2. So got a lot going on here. See if we can combine it. So 3 times negative 1 times 2, it's going to be a negative 6. And then that's cosine of sine of 2x squared times sine of 2x times cosine of 2x. All right, that's a lot for chain rule, but that is all the examples I have. So if you have any questions, let me know.